how to find forward and inverse kinematics, right? In this session, we are going to see how to find forward and reverse kinematics, okay, for 2 degrees of freedom robot, okay, right? So this is forward kinematics, and here we are going to see about reverse kinematics for 2 degrees of freedom. 2 degrees of freedom. 2 degrees of freedom of a robot. Right? It can be a manipulator. It can be an arm. It can be a robot arm. Right? Here we have a fixer. Here it's a joint. I can do the link like this. It is a joint, it's a link. It is a link 1, it is link 2. It is a robot manipulator. In this picture, you can see here you can get this 2 degrees of freedom. It is 1 and 2. Here you can get 2 degrees of freedom. Okay. Now, this picture shows, here I gave a picture, no? This is a joint. So it is a first point, it's a second point. So it is a joint. And this is a final point. So here we are, so it is given it as E. E means its end effector. E stands for its end effector. Here I am going to use the letter E for end effector. Okay. Now I am going to use 2 letters. This is X and Y. It is E of X comma Y. It is the location of this end effector at this position. Okay. Now I'm going to use these 2 distance. It is X and Y. It is this distance is our horizontal distance from this origin. So it is our origin, and this is our end point. It is so it is for our end effector. For our end effector. So we are calculating this total distance of this horizontal distance. It is X, and we are calculating this total vertical distance. It is Y. So you can get this 2 variables, both X and Y. Okay. If you are going for this link alone, right, we can find. So also here I am going to introduce a new term, which is theta. So it is theta 1. So this theta 1 is for link 1. So it is for link 1. And this theta 2 is for link 2. Here you're having link 2, no? There is a link 2. Okay. Now, if you are going to extend this line along with this link 1, then you can get theta 2. Okay. If you are going to compare with this horizontal plane, then you can get pi. Okay, simple. If you're going to add this theta 1 and theta 2, then you can get this pi term. So this is the angle with respect to this link 2 and the horizontal plane. Okay, so these are the parameters I am going to fix here for the 2 degrees of freedom for forward kinematics and for reverse kinematics. I will tell you what is meant by forward and this reverse kinematics later. First, I am going to introduce these characters in these pictures. Okay, so in this picture. Okay, now there's a length of the link 1. It is L1. There is a L1. Also, we having L2. This L2 is the length of link 2. Okay. Now we know the formula. So we know this trigonometry. No, if you are going to calculate this adjacent side, this is our. So it is our adjacent side. We can calculate. This is a L1 length. No, so you can find it is L1 cos theta. This is our adjacent side. So this adjacent side is related to this cos theta. Similarly, you can add this theta 1 plus theta 2. You can get L2 cos theta 1 plus theta 2. Okay. Students, can you able to follow me? Shall I continue? Are you there?
Yes, sir.
Yes,
Okay.
sir.
Okay. Okay. Thank you. Now, similarly, there's so the same procedure is adopted for this vertical lens. You can find this L1 sine theta 1. It's the length because it is related to its opposite side. So we can find this opposite side using this length. It is L1 sine theta 1. It is a basic trigonometric formula we know already. So similarly, we can find for this height, for this y is equal to L2 sine theta 1 plus theta 1 theta 2. So it is our length for link 2. So we found the length of link 2 and link 1. Okay, for link 1 and link 2. Okay. Now I am going to tell what is meant by forward and reverse kinematics. Okay. Now I am having the joint space. This is my joint space. We have a 2 terms. It is joint space and world space. So these are the 2 terms I am going to introduce now. What is meant by joint space? It is our basic origin. So it is our basic origin, or so it is our base point. It is called as joint space. So this is our origin. Okay. The next is called as world space. This world space is your final point or your end effector point. It is called world space. So these are the two things we are going to see. Okay. What is mean by this world space? Because this end effector is going to connect with the world, to its external world, or to some other robots, or to pick and place operation. So this point E is going to connect to the external world. That's why we are calling it as world space. Okay. This world space is related to XY because, so in the starting of the session, I told you already, this is X and Y. This E suffix X and Y is related to the position of end effector. Okay. So we are going to find this E, X and Y in this world space. And next is this is a total pi. So it is a summation of theta 1 and theta 2. No, it is pi. So we have to consider this X, Y, and this pi for this world space. Okay. For joint space, we have to consider this theta 1 and theta 2. Okay. So this is a two things or two parameters we are going to see. Okay. Now, if the problem, if you say, for example, if you are giving the problem to you, if I gave this theta 1 and theta 2, you are supposed to find this x, y, and pi, then it is called as forward kinematics. Forward kinematics. If we gave x, y, and pi value, you are supposed to find this theta 1 and theta 2, then it is said to be reverse kinematics. There is a difference between forward and reverse kinematics. So, of course, in both forward and reverse kinematics, you are going to find the length, angle, so these things. You are not going to find the force because in this kinematics, we are not going to consider force. Okay. So, this is a basic difference between forward and reverse kinematics. Students, can you able to follow me? Shall I continue? Shall I continue?
Yes, sir.
Okay. So this is my forward kinematics. So it is theta 1 and theta 2 is known. And you have to find this x, y, and pi value you have to find. So it is our given data and this is our solution, means this is our forward kinematics. If you're going for this reverse kinematics, then it is x, y, and pi value is known, or it is our given data, then you have to find this theta 1 and theta 2, it is to be solved. Okay. Also, we know that this pi is equal to theta 1 plus theta 2 because we can add. So it's a summation of theta 1 and theta 2. So it is well known. Okay. So because this is the total value pi, if you're going to sum this theta 1 and theta 2, then you can get this total pi value. So this is an angle with respect to the space plane or your basic horizontal plane. So this is the basic difference between forward and reverse kinematics for 2 degrees of freedom. For 2 degrees of freedom, you have only 2 links. For 3 degrees of freedom, you have to draw the 3 links. So it's a difference between this 2 degree and 3 degrees of freedom. Okay. And next is, still now we are not going to see about forward and reverse kinematics derivations. We saw as of now what is mean by forward and reverse kinematics. Yes. Here I have to tell you another one important point. This reverse kinematics is also called as inverse kinematics. It is often called as inverse kinematics. Okay. Students, have any doubt in this? If you have any doubt, then you can share now. Any doubt?